Hi everyone, I am Larry Lin of BenQ Dental Care, the CEO of the company. We are very happy to introduce our intraoral scanner today. Our lecturer, Dr. Joey Tang, will present you the evolution and the digital manufacturing process of aligners. Today, during the webinar, we hope you can share this webinar to your friend, and you can find out the password on the screen, and you can leave your comments, and you may get the bonus gift from your local dealers. We hope we can learn each other during this webinar, and we look forward to seeing your feedback. Enjoy it.
Hello, everyone. Today, I want to share with you a very popular issue recently, the in-office aligner. Before discussing the in-office aligner, we must first discuss the reason for the in-office aligner's demand. I think everyone knows why. Direct-to-consumer orthodontics creates demand for the in-office aligner. This is the Dr. Kevin O'Brien's orthodontic blog. I follow his blogs for years. This is the post at May 31. The UK dental regulator, the General Dental Council, has recently produced 3 related documents and highlight the main points of each one. The first one, a GDC statement on direct-to-consumer orthodontic treatment. They direct this to the dentist and other dental care professionals. They may follow points. Any innovation should not compromise patient safety measurement. Remember this point. Anyone who is not registered and practice dentistry could be prosecuted. Face-to-face interaction and or physical clinical assessment is necessary to ensure patient safety. The responsibility for the treatment rests with the treating dentist. Means we give the treatment to our patients. We have the responsibility. Direct interaction between the patient and the dentist is essential. Patients must be able to make contact with the treating dentist. They must know the full name of the treating professional. It means we provide the treatment to the patient. We have the direct connection with the patient. The direct connection between the patient and the dentist. So the dentist role is very, very important because they have the responsibility for the treatment. And now the second statement is they outline the more detailed the GDC standard that are relevant to the dentists who are involved in DTCO. The DTCO, direct-to-consumer orthodontics, there are many dentists to run the business model of the DTCO. The GTC and the regular, the dentist have their responsibility. And the third statement, they also produce advice for the patient who are seeking DTCO. I thought that is the main point of this. Without seeing you in person, the dentist might not have all the information they need about your oral health. To give valid, informed consent, you need to have been given all the information about what the treatment involved. Knowing the name of the person treating you is very important, as the dentist who prescribe your aligners or braces is responsible for all your treatment. Okay, this is the first government regular about the DTCO. I conclude this situation is there is no direct contact and the clinical examination of the patient's mouth and assessment of their dental health by a dentist. How anyone can assess the health of the patient's mouth by viewing photographs that are taken on a phone. The person who is responsible for providing the care, when care is provided by a dentist or orthodontics, there is no doubt that if there is a problem with the care, the treating dentist is are responsible for their patient, the regulators, and the legal system. As this new system does not involve direct treatment by a dentist, it is not clear who is clinically responsible for the treatment. But why the direct-to-consumer orthodontists are accepted by so many patients? There are many videos talking about the direct-to-consumer orthodontists on YouTube. Please read the message. Most people accept direct-to-consumer orthodontics because it's cheaper, much more cheaper than regular orthodontic treatment. Under epidemic of COVID-19, cost down becomes the patient's top priority. Patient wants affordable aligner treatment. That is the true story about the direct-to-consumer orthodontics. Only cost down the left fit make cheaper aligner treatment possible. In-office aligner become the best solution. Direct-to-consumer orthodontists try to do our job. I ask one question. Can we do their job? Can we make aligner in our own office? I made aligner in office for more than 10 years. Let me tell you the story. Let's go to the in-office aligner. I talk about the benefit of the in-office aligner. Cheaper, save up to 70% on aligner that bill. Maybe this may be more. Second point, high quality aligner designs ready for approval. I made treatment planning and set up by myself. No need to approve. I approve my own treatment planning. And the next, aligners can be stitched in just a few days. Maybe if you are very familiar to the procedure, maybe you can keep the aligner in the visit on the same day. You can give the patient the first aligner, and then you have maybe 10 to 14 days to produce the rest aligner. And the next, the lost or damaged aligner no longer an issue. If you keep the model, you can give the patient a new aligner right away, not to wait, maybe 10 minutes, maybe 20 minutes. The last, aligner case fit can be more affordable because the cost of the aligner that fit is very, very low. Okay, this is the benefit of the in-office aligner. And now we proceed to in-office aligner procedure. First, I want to introduce you the in-office aligner digital workflow. There are 4 steps to make in-office aligner. Are you interested in getting in clear aligner therapy but unused? They are really work. Are you a general dentist interested in getting into orthodontics but not know where to start? Are you an orthodontist ready to reduce your clear aligner lab fee? Do you want to be able to 3D printing your own aligner in office affordable? There are 4 simple steps to make in-office aligner. The first step is take a digital impression. Now the technology developed very, very fast. It's no longer to make a traditional impression. You have the intraoral scan, and the intraoral scan make the impression much more efficient and much more easy and much more accurate. And it takes very, very easy to get the impression digitalized. Okay, the second step, when you scan your patient's mouth, you have SDL file, the digital file of the dentition, and then you put the digital file into a software, and the software can let you to make your treatment planning and set up the tooth alignment and to set up your step of the tooth movement, how much the tooth move and move direction, the angulation, everything in the software. As your treatment planning and the setup is done, you will create many steps of the SDL file. Every step of the tooth movement is SDL file, and then the SDL file you can put it into the 3D printer to output a real model, and the real model comes out, and you can proceed the manufacturing. The thermoforming aligner is quite simple. It is not very easy, maybe several years ago, because the intraoral scan is very, very expensive, and the software is not so popular, and the 3D printer is very expensive. So at the very beginning, I used the milling machine, but the milling machine is not very good for the orthodontic model output, because the milling machine it had a longer time to milling a single model, and one machine only can milling one model at a time. But the 3D printer can print maybe dozens model in one time printing. And the thermoforming aligner is old technique. We use the thermoforming clear retainer for many years, and the material is is ready for our use the same material to do the clear aligner and the clear retainer. So it's very simple 4 steps, and now we go to the detail of every step. First is the digital impression. Okay, we want to introduce you a very good intraoral scanner, the BenQ intraoral scanner, BenQ DIX1. According to an informed survey conducted by the Journal of Clinical Orthodontics, 60% of the respondents indicate now they use an intraoral scanner. The speed of the scanning has increased such that it can be faster than taking an arginate impression. Once the time of the preparation and the cleaning up is factored, the majority of the patients prefer being scanned to having a tray of arginate stuck in their mouth for 2 minutes. Some doctors worry about the cost and the learning curve of the transition to intraoral scanner, but there are minimal obstacles. At the very least, an intraoral scanner is the entry point for in-office aligner, because aligner is totally digital follow-up. It is the product of the digital dentistry. So the first point of the in-office aligner is the dentition data digitalized, and the digital impression become the best solution. The question of which scanner to buy is indeed relevant, but most aligner programming software will accept any STL file, the output file type of the most scanner. The scanning procedure, it is quite simple. Just practice a lot. The assistant can also do scanning after training. My assistant is doing better than me. This is the BenQ DIS1 scan. My practice is quite simple, and very fast and easy. You can see now I scan the approach. You see the quality, the scan quality is very, very good and very, very fast. And the BenQ VIS1 is, you can see the BenQ DLP projection technology. BenQ have the very high-end technologies about the DLP processing, digital light processing. And you can see it win many, many awards. The production of the intraoral scanner, the BenQ VIS1, they have ISO 13485, and it also export to the Thailand and Malaysia and Europe. Now you can buy, you can have the BenQ VIS1 very easy because it is cheaper than switcher and cheaper than iTero, and with the same high quality of these intraoral scanner. Okay, now this is the production, the test of the BenQ VIS1. Okay, after introduce the digital impression, and now we go to the second application designer, the software. Set up software, you can make treatment planning, and you can design the alignment. The device design is design the alignment. You can see the software. You will, when you set up your every move, every step of tooth movement, and every step tooth movement, you will create a STL file, and the STL file will output to a real dental model for the thermoforming procedure to create the alignment. And the software, every software have the function. You can record to animation. You can see we can view the animation to watch the tooth movement, and the right side here is the follow up every time. Every time patient come back to office, can photo coincident with the animation. Now we can see the for example the step 32, and here we enroll the animation to the 32. We can compare the animation and the real situation in the patient's cavity. You can see almost the same. And we can see the next step 44. And we check the step 44. You can see the animation and the oral cavity. The real situation is very, very similar. It means your treatment planning is good, your tooth movement is okay, and the final result can be expected. And now we can see the lower arch, the same. We can examine, for example, the step 32. Okay, you see the 4-3, the canine, the original position, and to the we design the position. You check the image of the step 32 with the animation. You will see, yes, it works. This is extraction case. So if you see to the 50, the original position here, the step 0 to the step 50 is going well. So there are many software in the market you can choose, but the setup is the most important step in the aligner procedure. It consists in virtual movement the tools to the intended outcome. The software give you complete control on the treatment planning for advanced customized of each case. The number of aligners to reach the goal is calculated in real time, which each new movement, maximum tooth movement value are adjustable for each tooth, depending on different parameters, such as the patient's age or the elasticity of the aligners. Complex movement can be accelerated by adding attachments. Strippings is therefore stimulated. Occlusion and the collisions can be controlled in real time. It is also very easy to introduce independent sequence to manage, for example, a pre-digitalization or an overcorrection. So to avoid any confusion, a 3D engraving system materially included in the step numbers. Many doctors are excited about 3D printing and the possibility of making in-office aligner, but do not want to go through the process of creating a treatment setup. A smart way to getting started with doing in-office aligner is the option to outsource the case setup and the design. If you don't want to spend time to making treatment planning and to make a setup, you can outsource to setup company. There are many companies right now. You can outsource to this company, but in my opinion, you can do it by yourself, and you are learning a lot from to make a treatment planning and to set up a case. And you will find after you are doing cases, maybe over 20, maybe over 30 cases, you will become very easy. It won't take you a long time to make a treatment planning to set up a case. It's very easy. And now maybe I only spend an hour to set up a case from the beginning to the end. Just 1 hour, you can finish a case of the treatment planning and set up the tooth movement. There are now multiple companies offering treatment planning and the design service that can provide the doctor with file ready for 3D printing. The patient models for in-office aligner. Typically, from my experience, the design portion has always been the limit and the more challenging step in office aligner workflow. But you must do it by yourself. It's not so difficult. Please do it by yourself for cases, and you will find it become more easier after one case, and more easier the next case. And after times go by, you will become it's very easy for you to set up. And maybe at that time you can run a company to set up a treatment planning and set up a case for other doctors, other dentists to make money. Okay, now we talk about the digital output. 3D printing the model for aligner fabrication. The real model for aligner fabrication. This is a printer I use, the Taiwan product. This is my lab. I have a large 3D printer. The large one, the advanced series, professional series, print up to 16 models every 30 minutes. And the small one, it can print 3 to 4 models every 20 minutes. It's very, very high efficiency and with very high accuracy. And since we talk about the 3D printer, now I want to discuss with you something about the 3D printing. This is the main image of the right side is the Invisalign aligner, and the left side is my own in-office aligner. The patient asked me the question. They say the Invisalign aligner have some irregular, such like the fingerprint in the aligner, and why my aligner is different from the Invisalign aligner. Can your aligner works? Okay, there is many same question from other patients. So I want to explain you how these fingerprints make. Why the aligner has such irregular on the aligners. It is 3D printing character. Okay, I want to explain this, and maybe I want to explain you very carefully, because the starting point for any 3D printing process is a 3D digital model, which can be created using a variety of 3D software programs. In industry, that is a 3D CAD by makers and consumers that are simple, more accessible for programs available or scanned with the 3D scanner. The model is then sliced into layers like this. Okay, the model are sliced into layers, thereby converting the design into a file readable by the 3D printers. The material processed by the 3D printer is then layered according to the design and the process. As stated, there are a number of different types of 3D printing technologies which process different materials in different ways to create the final object. Functional plastic, metal, ceramics, and sand are now all routinely used for industrial prototyping and production application. Research is also being conducted for 3D printing biomaterials and the different types of food. Generally speaking, through at the entry level of the market, material are much more limited. Plastic is currently the only well-used material. Usually ABS or PLA, but there are now growing number of alternatives, including the nylon. There is also a growing number of engine-level machines that have been adapted for full stuff, such as sugar and chocolate. So 3D printer can print everything in the future. Anything, food, clothes, and now we print the dental model. Is very easy. Now, at the time, the 3D model slides into a layer that I will show you what is the layer look like. This is the same model I used to slice the models with the layer thickness 0.1 millimeter, 0.15 millimeter, 0.20 millimeter. The same model, so the same model height, but with the different layer thickness. the same model height. If you slice with thinner layers, for example, 0.1 millimeter, it will totally slicing layers, 134 layers. But if the layer thickness is 0.2 millimeter, it becomes half, only 67 layers. Okay, and the print the layer by layer. So if you slice the model with thinner layer thickness, you will print more times. And if you slice the slicing layers is much more thinner, and you will produce less layers, and it means the less printing times. But if you look at the same height, at the 6 millimeter height, the 0.1 millimeter layer thick, it will at the 60 layers, and the 0.15 it will go to the 40 layers, and the 0.2 millimeter it will come to the 30 layers. You see, at the same height, the cross section of the layer is almost the same, the same height is almost the same of the image. Okay, and then I show you what does it mean. Okay, the same situation, same model with different slice layers. When you slice with the 0.1 millimeter, it creates 104 layers, and 0.15 millimeter, you will become less layers. It goes to the 70. And if you use the 0.2 millimeter, you will become half number of the layers compared to the 0.1 millimeter. You see, what is the difference? We highlight the tip in sensor tip. You will see the step between layer and layer is more apparent when the slicing layers is thinner. The more thinner the slicing layers, it will create more fine surface texture. If the layer become more thinner, and the surface, you will create more irregularity of the surface. And this is the same STL file. I print in 3-layer thickness of the printing setting. You will see almost at the same. The model create the same model, but you see the surface texture. You will see the thinner the layer, the slicing layer, the smooth the surface texture, and the more thinner the layer thickness, it create a more irregular surface texture. And when we use the different texture to create a liner like this, we create thermoforming material. You will see the thermoforming material, you will fit into the irregularity on the model surface. Okay, let's go to the real situation like this one. The same patient, the same model, but the different layer thickness of the 3D printing model, the same thermoforming material. Can you see the difference on the in the tooth mouse? maybe it's not very clear, but if you highlight them, you can see when the layer thickness is thin, the irregularity is not so obviously, not so apparently. It's much more smaller. But if you print with the printing the model with thinner layer sizing, you will create much more irregularity apparent on the surface. So it explains why the aligner have such fingerprint-like texture on the aligner, and this is some aligner brand their commercial video. You see the transverse lamina. It is the nature of the 3D printing. It is not make the transverse lamina by purpose. It is the nature of the 3D printing model. And another issue is some patient ask me, patient say, do you have the direct 3D printing aligner? Okay, I try to direct 3D printing aligner. This is the 3D model STL file, and I cover it with a thin layer of the cover the model with a layer of 0.6 millimeter, and then I create the STL file, and I direct printing the aligner with the 3D printer, and you see what happened. This is the direct 3D printing looks like. Yes, there are so many supports, and it have more than 100 support because the 3D printing technology now I use. The aligner should have, it must have the support to printing the aligner. And when the printing is finished, and I have to remove the support, over 100 supports, and it takes me longer than 2 hours. Okay, that's after I remove all the supports and put it back to the model. Yes, it can be done, but you see, because the material I used to print did not have the physical character with the aligner or the thermoforming material. It is not so elastic, so it breaks. So the rest 3D printing aligner can be done. Yes, I believe maybe in several years later, when the material is ready and the 3D printing technology is ready, and then 3D printing aligner will come to the market. And at that time, we don't have to, we can direct create the aligner STL file and the direct 3D printing the aligner. It will save much more time than right now the manufacturer time. But I say it will take time, and right now are not available in the market. Okay, the in-office aligner digital flow 1, 2, 3, 4, and it's quite simple. But maybe you will ask me the final question. Manufacture the thermoforming aligner, and I will introduce you the BenQ EG the thermoforming material. It's made in Taiwan. And the clear aligner system apply dental biomechanics to create dental orthodontic force to move your tooth into the desired position. Easy do is easily to be thermoformed in two aligners and keep superior orthodontic force under thermal oral temperature. EasyDo has outstanding sustained the ability to strike a balance between alignment efficientness and wearing comfortable. According to the here is according to the ASTM E2254 using the DMA dimensional mechanical analyzer. EasyDo has the better performance in the orthodontic force, and the maintaining force is better than TPU. Maybe you say TPU is better. EasyDo have a better performance. And then the thermal forming machine. I think everyone has the thermal forming machine in your clinical office. And this one, my first thermal forming machine, I use it more than 30 years. It is still can do their job very it also can do their job. And this is my second thermal forming machine. And recently I have this one. This is the thermal machine. And this the mini star is the thermal place. From the top of the thermal forming material, you will place the thermal forming material on the model. It works well. All these machines, it's not problem, and it's not so many expensive, and it's already in your office. Okay, the manufacturer. This is my job. I create these aligners by myself. I set up the treatment planning, and I set up the case. I set up all these STL file, and I print this model by myself. And then I produce all these aligners. This is 2016 summer in a Sunday morning. You see, I have spent a lot of time to trim all these aligners to here. It takes me a whole day to do all these aligners. So you can see the manufacture is also a time-consuming job. Maybe you don't have to do it by yourself. Maybe you can ask your wife to do this job. Okay. The 4 steps, 1, 2, 3, 4. Now you can produce your own aligner for the patients in your office. But the last question is this: does it work? How is the clinical performance in the patient's mouth? If you can make the aligner by yourself, but if it doesn't work, patient won't accept. Patient care about the money is cheaper, but patient also care about the result. So the clinical performance, does it work? I show you a case. This is a class 3 anterior crossbite case. Let's check the occlusion. In the centric occlusion, canine relationship is close to class 1. But if you push the mandible to the central relation position, anterior teeth become edge to edge. It means there is functional shift from CR to CO. In the software, I can ignore the occlusal interference. This is the power of digital data. The real plaster model cannot do that. Push the mandible upward to the centric occlusion without functional shift. At this position, you can see the canine relationship goes to class 2 relationship. If you do not find the functional shift, direct proclination of the anterior tooth to correct anterior crossbite. After anterior crossbite correct, you will find upper anterior tooth will be too proclined and with a large object because the occlusal interference is gone. And centric occlusion goes to class 2 relationship. The class 2 relationship correction without instruction with aligner treatment, usually by the molar digitalization, to create space for class 1 canine relationship. Since the lower arch looks good, so my treatment planning is to correct upper arch alone. After anterior crossbite corrected, scan again, and goes to refinement. This is the animation of staging. Upper molar movement first to create the space for class 1 canine relationship, and then anterior proclination for the anterior crossbite correction. The final position of the incisor edge. The final position of the incisor are just a little bit proclined. Every time patient come back office, take photo to check progress with the animation. We can see the step 20. Okay, we go to the step 20. You check the photo with the animation. You can see almost the same. Photo quite match animation. Everything seems go well. And then we go to 43. Yes, it also going well. And then we go to the step 52. The treatment planning and the staging setup meet expectations, but something bad happened. Here, watch the lower arch. My treatment planning is the upper arch aligner treatment alone. At step 20, you can find lower arch appear space between anterior teeth. That is because of upper arch weighting aligner and the lower arch dip along. The upper arch aligner push lower anterior teeth labial proclination and the lower anterior space appear. At this moment, I put the braces on lower arch and the power chain, hopefully to close the space. But at the step 43, the situation get worse. Space become more large because at this time, upper anterior begins anterior proclination. It makes aligner more anterior. And here, I put bi-turbo on 36 and 46 to disocclude upper and lower arch. Finally, at step 52, lower arch space closed and the anterior cross-bite correction was done. What I learned from this case, if the lower arch were maintained aligner from the beginning, the lower arch will be no problem. The first stage finished before and after a profile photo. You can see the lateral profile photo. Upper lip not changed because anterior teeth just a little bit proclined, but mandible shift backward because the functional shift was normal exist. I prefer to leave it alone for a short period of time before go to the refinement stage. And then I scan again and go to refinement. You can see the final result is good. The lateral photo shot. Again, take the photo to check the progress every time patient come back office. Okay, patient's cheek complaint, anterior crossbite correction is done, but patient is not happy about the upper incisor morphology. There were incisor edge wear because anterior crossbite. So I scan again. Distal was up with DSD software like this. And then according to the digital WhatsApp design, a direct composite resin built up former, linear former, and the 3D printing output real former. Add some resin, composite resin in the former. Put the former into the right position. After liquid the composite resin, remove the former and polish, just like DSD mount-up procedure. This is the final result, and the patient is very happy. From the beginning to the final result. Aligner treatment works. In-office aligner. What do you need to do to make in-office aligner? Orthodontics practice that partner with the dental lab benefit from accelerate turnaround without needing to purchase a printing solution, learn new technology, or hire a technician. In-house 3D printing production of aligner is the best option for practice that want more profitable and faster service. Orthodontics practice that integrate a 3D printing solution into their operation gain full control over the working flow and achieve faster production turnaround time. Also, aligner production can begin as soon as the patient is ready to undergo oral scan. Practice can provide same-day service. In a same-day appointment, orthodontists can take oral scans and print out treatment and print and form the first aligner stage before the patient leaves the office or within a few hours of appointment. The expected service provides optimal customer service and immediate customer lock-in advantage. The accelerated turnaround reduces the treatment planning schedule setback caused by lost aligners, treatment planning adjustments, or ear-fitting aligners. If the treatment planning needs to be adjusted, 3D printer can produce new aligner in a single day. In the event of misplaced aligners, the increased production speed allows the patient to obtain a replacement set before their teeth strip out of alignment or go on a trip. Among these benefits, starting in office aligner production has two challenges. First, the printing solution needs to be either purchased or leased, requiring an upfront investment. The practice team must learn to operate the machine correctly or hire a knowledgeable technician to run production. While 3D printing aligners in office aligner requires that practice invest time and money, eliminating debt and the ability to provide same-day service justify the investment by increasing profit margin, decreasing treatment timeline, and improve patient satisfaction. Also, another very important factor is the patient, because the aligner treatment is not just only 1 month treatment. Normally, it takes more than 1 year. If you want to do in-office aligner, please carefully evaluate the investment, the time, the benefit, and you have to ask self a question. Do or not do. Carefully evaluate. If your answer is yes, I do. Okay. Congratulations. Welcome to the digital world and enjoy the game. Final, BenQ is always with you. Can provide you the total solution to the in-office aligner production. Thank you very much.
Dr. Cho, thank you very much for your wonderful lecture. Guide us how to implement in-office aligner into the practice. There are tons of questions coming from our participants. Question number 1, why do you choose EasyDeal in your in-office aligner workflow?
Compared to other brands that I have used before, EasyDeal is not easy to crack or break. EasyDeal has outstanding sustainability to strike a balance between the alignment effectiveness and the wearing comfortability. Besides, EasyDeal is easy to be thermoformed into alignments and keep superior orthodontic force under normal oral temperature. Quality advantage is the reason why I choose EasyDeal to be my in-office aligner material.
Thank you for your insight. The second question is, why do you employ BIS1 in your in-office aligner workflow?
Okay, the body weight of the BenQ BIS1 is light. I don't feel tired as I scan many patients in one day. The tip size of BenQ BIS1 is suitable for Asia. I can operate scanner easily in the patient's mouth. And the most important thing is the file exported. BenQ BIS1 export open file format, the STL file. After complete scanning, I don't need to upload scanning data to cloud and then download from cloud for file format conversion. Lightweight, smaller tip size, and open file format are the reason why I recommend BenQ BIS1 scanner.
Thank you for the information. As the webinar time limitation, Dr. Cho and our BenQ team will try to reply each and every inquiry or questions left in our message area. So please feel free to keep sending us your messages. Thank you, Dr. Cho. We all enjoy your very useful speech.
You're welcome. See you next time.
See you. Hello, everyone. I'm Shannon, Senior Sales Manager for our International Business Development. Lastly, I would like to introduce why BenQ DigiDent is the brand you can trust for digital dentistry. BenQ KISA has a leading digital light processing technology. Hereby, we concentrate on our BenQ Intraoral scanner and further develop 3 solutions, which are Q Precision, Q Smile, and QICB. Let me explain each and every solution. First of all, the green color mark in the circle is the surgical guide solution defines Q Precision. This part, I would like to introduce our chair-side surgical guide service. Dentists can use BenQ scanner to scan patients' mouths. Our scanner can output STL and OPJ files, and then use our surgical guide treatment plan software, Mercury, to import patients' copy CT data and scan data. Mercury supports OPJ files. In Mercury, dentists can use computed tomography to obtain bone quality information. The OPJ file format from BenQ scanner is to obtain the color information to design treatment plan. After the treatment plan is completed, we provide surgical guide design service. According to the dentist treatment plan, we will design the surgical guide and produce the surgical guide from our lab. Or we will provide the digital file. Then dentists can cooperate with our recommended 3D printer to produce the guide in clinic site. Finally, during the surgical operation, the dentist can use universal guided toolkit developed by BenQ DigiDent to perform the operation. The stopper drill with cooling design and the guidance of the surgical guide can both be beneficial to an accurate surgery operation. Secondly, the red color mark in the circle is aligner solution defines Q-Smile. Dentists use BenQ scanner to scan the patient's mouth. Our BenQ scanner can output STL and OPJ files, and then use the aligner software to design treatment plans. To print models, you can use the BenQ 3D printing model resin, cooperate with our recommended 3D printer. And finally, you can use BenQ EasyDew to thermoform the aligner. There are 4 different thickness specifications. Either you can use 0.75 millimeter for clean aligner, or use the 0.5 millimeter and 0.6 millimeter for an attachment aligner, or you may choose 1 millimeter for a retainer. Next, the third one in the circle shown blue color is Digital Implant Solution Device QICB. ICB stands for Implant, Crown, and Bridge. BenQ DentCare is a joint venture company of BenQ Kista and AB Dental Device. We incorporate with AB Dental enriched digital prosthetics parts to scan the patient's mouth. Then BenQ scanner generates STL and OPJ files. You can export to design software, SOCADE, 3Shape Dental Studio, or EasyCADE. And finally, use mini machine to make digital dentures. Those above 3 solutions illustrate BenQ AB DentCare has a lot more digital dental products and service, and new products are coming to the market soon. We will continue inviting all of you to join us in the next BenQ DigiDent Plus course series. Don't forget to like and follow our Facebook fan page so you won't miss out our event. Thank you for your time and participation.
Hello, my name is Elaine, and I'm Intraoral Software Training Specialist. I'm very glad to have this opportunity to introduce the one of our most user-friendly software called EasyCAD Lite. We believe that EasyCAD Lite will be a great investment to your operations. After research and developments, Intraoral has succeeded to create such a smooth operation workflow for dentists and clinics with our softwares. You can easily upload your scan data with BenQ and then upload it to our software. And then beside software, we could also provide training and lectures. And in fact, on July 4th, we will have lectures in Taiwan. Everything about EasyCAD Lite, like the name itself, is light and easy. You could design the form and export all in fewer clicks and shorter times. And now I'm going to show you a demo of how to create an anatomic chronic crown with EasyCAD Lite. And our case suit would be 2, 1, 1, 1, and 1. Right. So first, we could run the software, and then we could just create order and choose the folder and the scan data. That, and then just like what I've mentioned, our suit is 2, 1, 1, 2, and 1, 1. And then we have to connect this dot, and then okay, click OK. And we're gonna wait for it to run for a while. And now we're going to adjust the occlusion. We could easily adjust it with your mouse, but I usually do this with this axis with the help of this horizontal and vertical axis because it makes it easier. And we could only just like focus on this tree, the crown that we want to operate, this part. And once it's already inside the circle, that means we're good. And then we could just click next if there's no further edit needed, but you could course, always edit as much as you want. And now we want to draw the margin. And with EasyKit Lite, you could draw the margin with just single one click like this. See, it's very fast, it's very easy, and you could see if there's needed any adjustment, but I feel like this is good. And then moving on to the next suit. One click, and there you have it, your margin. All right, now we're going to adjust the angle so that we could have a perfect angle of insertion. Right, now this looks better. And we're going to build the parameter. We don't really need to adjust anything because everything is automatic already. But of course, if you want to, you feel free to adjust. And then we could just design the crown and the shape of the suit and the teeth and the jaw using these functions. So what I usually do is I make everything a little bit more transparent so I could have a fuller control and a better vision, something like this. And I could enlarge the teeth. I could adjust the angle. I could adjust the height, position, something like that. This. Okay, just let me do a little bit, something like this. Okay, and here in this button, you can see the upper view, the below view, front view. You could just click whenever you like it for your better design process. Okay, just gonna do this a little bit. Yes. Okay, just make it a little bit to the front. Something like that. Make it a little bit smart. Okay, adjust. So you can see here, this is very, very easy. It's like a game. It's like a 3D, something like that. So yeah. So once you feel like it's good, wait, hold up. Ooh, okay. You can click next and click yes. And then let it just wait for a while. And here we can adjust the crown. For instance, if you want to smooth the surface, you can click smooth and just smooth a little bit here, something like that. If you feel like everything is done, it's good, then it's okay. And if you want to add something, remove something, you can do it. And click yes. And then here is the connector design. You see there's two colors, yellow and red. We don't want that. We want a green connector. So what we can do is click to this connector and move it, make it bigger. And until it's green, that means you're good. And you can adjust it here. If you feel like it's way too up front, maybe, you can just adjust. And then click the red one, just make it bigger until it's green, make it a little bit thicker. And there you go. Okay. And there you have it. It's all green. It's all good. Click next. And there you have it, your anatomic panic crown. And now I'm going to give you another demo, which is an easier demo for a temporary crown. So let's just close this project. The same order, we could just start from create order, click add, and then this one, provisional crown. Just your folder, choose data. And because this is unknown, you can actually click this to preview. And here you can see that, oh, this is lower jaw. So yeah, we can just click the lower jaw. And because we're going to choose the 237, choose 37 and then provisional crown, and then click OK. And let's just wait for a while. Same thing, occlusion. And we would just wanted to focus on the T37, so this one. So once it's already inside, that means we're good. It's a little bit different from the anatomic panic. Here we have to draw it a little bit manually, but it's not really that hard. You just need to click and draw a circle surrounding the tooth. until it made the first button. And then once it's okay, that means we're good. You can check whether it needs any adjustment, like maybe you feel like this is way too, a little bit jumpy, like that, or you can add more. Okay, now that's good, click next. And because this is automated, so you can see here we have a two combination of colors, purple and gray, and this is exactly what I want. This combination means that the shape is exactly the same like the real two. We could actually make this a little bit transparent. So could you see the crown model of it? And again, just like before, you can smooth it down if you feel like it's needed. And then maybe a little bit touch of here and there, and then you're done and click next. And there you have it, the temporary crown. It's easy. I don't think it's more than 5 minutes. All right, now for the very last demo, it's actually for our e-model. So with EasyCat Lite, you could not only create a crown, but also you can create an e-model. So first, same order, you choose your folder and scan data like this. And because we're just gonna like design a model, we don't really have to focus on like which one to choose. And yep, same, the occlusion. You have to turn this upside down and everything. Makes it good. And because we want it to be very balanced, to very, how to say, like in a perfectly angle for the model, we have to like very took attention on this too. Okay, I think we're good. Okay, now we could click next. And we could click design e-model. Let's wait for a while. And then we could adjust the height, something like this. And then you could click next. Something like this. And then with this e-model, you could actually add some text, like maybe hello, and then click add. And we could just like maybe put it here. Now we're good. And then once it's okay, you could add the support and click edit. Just like put it here, like that. That was one, and then the other one. Okay. Okay. Just like put it here, and we could just like adjust the angle like this. I think it's good. And then you can choose the surface, whether or not you want it to be hollow or you want it to be like flat surface like this. I want it to be flat like this, so it's gonna take off this tick, and then you choose your printer and then click next. And then there you have it, your very first e-model. So it's very easy. It's just a bunch of clicks. All right, now we're going back to our presentations. Okay. All right. So after you saw our demos with temporary crown, you could also see that it's very easy to create permanent crown with your milling machine. And then of course, you can also print your, with your e-model. And then if you're interested with this software, we have actually a full version of EasyCat. It has a more in-depth functions such as veneer design. And it's also supported with AI automations. In the near future, we would like to achieve an even better, effortless, and seamless workflow between dentists. And yeah, my presentation's end here. Thank you very much for listening. And for those who want to try EasyCat Lite yourself, we will be happy to give you a free trial. And if you have any further questions, we would be happy to answer it. Thank you.